Hi, this lesson's about synthetic division. Synthetic division is used for polynomial division, and it's an alternative to long division. It streamlines the process. For synthetic division, it's important to note that the divisor needs to be degree 1, a binomial, and otherwise you need to use long division. So I'm going to demonstrate the long division method and side-by-side synthetic division so that you can compare the two and see how they vary. With long division, x plus 1 is the divisor. The dividend is the cubic function that I'm writing now. And on top, I'll write the quotient. I work on the basis of the leading term. So I look at the x cubed and x, and I know I need to multiply by x squared. So I line that up under the x squared column, and I multiply the quotient value by the divisor, and I line up the terms and subtract. The first term, if I've chosen correctly, will always cancel, and the second term I subtract, leaving x squared. I'll take the next term down. I'll consider the leading degree x squared with x, and this time I know I need to multiply by x in my quotient. I'll multiply quotient by divisor and get x squared plus x. I'm going to subtract this. Again, getting negative 5x, take away x, or negative 6x. I'm going to bring this term down. Again, I'm going to multiply this time by negative 6 to get negative 6x minus 6. And when I subtract this, I get a 0 remainder. Now remember that a 0 remainder means that x plus 1 is a factor of the cubic, because there's no remainder. Now let's compare this with synthetic division. First of all, notice that there's a lot of waste here. I line up the x cubed terms, I line up the x squared terms, I line up the x terms, and I line up the constants. It's understood that this column is all x degree 1 and x degree 2 and so on. There's a lot of repetition of duplicate terms. Also, this is, for synthetic division, it's understood that I need to work with a binomial that starts with x. So with synthetic division, what I'll do is I'll take advantage of that knowledge, and I won't even bother writing the x plus 1. I'm going to just remove that and only look at the coefficient. What I'm going to do generally is called detached coefficients. I'm only going to look at the number part. I have 1x cubed, I have 2x squareds, I have negative 5x to the 1, and I have a negative 6. I carry this 1 down so that I have something to multiply, and the 1 times 1 result is written here. I subtract in a similar fashion to what I did over here, and in fact this 2 and this 1 are just like this 2 and this 1 here, leading to a result of 1. I multiply 1 by 1, getting a result of 1. Again, I subtract, this time getting negative 6. I multiply, I keep putting the answer here, I subtract, and this last part is the remainder. I like to put it in a box to remind myself it's different than the other part over here, which is the quotient. What I need to do now is just interpret this. The negative 6 is a constant, so the 1 represents 1x, and the next one represents x squared, and the fact that they're not negative means they're positive, and I'm adding. Now if you look at the long division, right there, it's the same as the quotient I got by synthetic division. Much less writing in synthetic division. Now some people learn it the other way, where this number gets the opposite sign. I flip the sign of the divisor that I'm given, and instead of subtracting, I add. That would work equivalently well. In fact, why don't I write that out just to show you. So we would still detach the coefficients of the dividend, the same as before. Still going to carry that 1 down. But over here I'm going to write the signed opposite of the divisor plus 1. I multiply, but now I add my results. Multiply, add results. Multiply, add results. So you see, you get the same result either way. I like to do it with subtraction the way that I showed you, because that's how it was done in long division and how you've learned it in the past. Now, there are a couple special cases I want to talk about. First of all, if terms are missing, you have to account for them by using a coefficient of 0. I'll give you an example of that. I might have x cubed minus x divided by x plus 1. Notice that I'm missing a degree 2 term and I'm missing a constant. I will write my 1 representing x plus 1. I will write my 1 representing x cubed, but 0 representing x squared. My negative 1 for x, and 0 representing the constant. I'll carry my 1 down, multiply, subtract, multiply, subtract, multiply, subtract, just like I did before. And what I find here is that I have the quotient of x squared minus x plus 0. So it's the same process as I showed previously. You just need to account for missing terms. And as I'm looking at my quotient, I should just make a comment about this. One way you can check your work is the quotient multiplied by the divisor should equal, I'm putting a question mark there because I'm questioning whether it's true, but it should equal the dividend. If I multiply this out, the FOIL process, first, outer, inner, last, I get x cubed minus x, and indeed they're the same, so there's my check. All right, there's another special case. The other special case is a divisor with a degree 1 term coefficient that isn't 1. So far my divisors were binomials, degree 1, and they had a coefficient of 1. For example, of special case B, what if my divisor was 2x minus 1? The coefficient here is not 1. What I'm going to do is I'm going to divide by 2. That leads to x minus a half. And now I'll work with this. So let's set up a problem here. 4x cubed plus x squared minus x minus 1 divided by 2x minus 1. All right, well, I am going to rewrite this as x minus half. So I'm going to write my negative half here. I will detach my coefficients, degree 3, degree 2, degree 1, and constant. Carry my 4 down and multiply. I'm subtracting. So I have 3 and I multiply, and unfortunately I'm going to have to deal with a fraction here. Subtract and get half, multiply and subtract and get negative 3/4. Negative 1, add 1/4. Negative 3/4 is my remainder. Okay, now the quotient that I get is actually not the correct quotient, because don't forget I didn't divide by what I was asked to. I had divided by half of that value. So I need to take this quotient result and I need to divide it by 2 as well to get 2x squared plus 3x, 2x squared plus 3 over 2x plus 1 over 4 is the correct quotient. My check would be to take the quotient that I just wrote and multiply it by the divisor as presented, 2x minus 1, and see that I get the correct dividend. And I'll leave that for you to do. You can pause it and check that. All right, I've set up 2 practice problems for you to try. And what I'd like you to do is copy them down, pause this, then try working them through, and then check my results and my commentary about the problems. All right, back with you, and I have the solution written out for the first one. Notice I presented it in the wrong order. I did degree 3, constant, and degree 2, and there's no degree 1. You've got to take care of that. So you need the degree 3 written first, degree 2 written second, the 0 coefficient of degree 1, which is missing, then the 1, and then you carry out your operations. Remember the last number there, that's my remainder, and the other factors, or coefficients rather, make up the quotient. And the fact that this has remainder means that x minus 2 is not a factor of that cubic. Now try the second one and pause it. Alright, I'm back with you, and here's the second one. This is one of those cases with coefficient not 1, so I divide by 3, rewriting it as x plus 2/3, and I use the 2/3. All my coefficients are written here in the right order. Carry out the operations. Notice the remainder is 0. This quotient is 3x minus 6, and I need to divide it by 3 because my divisor was divided by 3. So x minus 2 is the quotient, and it's a factor. All right, that's the basics of synthetic division.